Good day, dear professor. So I would like to share my thesis progress that we achieved so far. So before jumping to the current thesis, let me just recap the results that was achieved before and uh, that our current progress is based on. So if you remember, we in the first um, in the beginning of this year we developed teleml application, which was just telegram application that utilized some machine learning models, and we developed in cross-platform applications, and we deployed on desktop environment. We learned some pros and cons of this approach, that every uh, all the parts of this project was developed in Python, starting from UI to uh, Telegram client API and ML utilization tasks. And we learned that, and this work was also published in INA 21 conference. And after learning, after experiencing uh, the first version of the TeleML, um, I planned to develop the second version of the TeleML that is improved. That I decided to choose more robust framework, which would allow us to to have more to have nicer UI, to which lets us to have more, let's say, more opportunity to try different, let's say, ML frameworks, and which we could cover uh, several devices, uh, and which would also consider performance considerations, right? So um, in the beginning, I was trying to follow and implement this architecture. That is, if you remember, it was this architecture is consisted of two parts. The first part is about machine learning cloud. Right here, this is just a machine learning marketplace where ML developers could upload their modules, and users could see these ML modules through UI, their profile, like Google Play Store, how users see applications for Android, right? And the client um, applications, which is shown in the client part of this architecture, they would download these ML modules and execute these MLs uh, on the Telegram clients, which were um, supposed to be implemented in the client applications. After deep analysis of this architecture, I understood that this architecture would bring some headaches for us. For example, we know that especially machine learning models require some, let's say, certain conditions to be run successfully. Although there are, let's say, um, available machine learning frameworks for mobile devices, but it it doesn't give us flexibility, because mobile devices, not only mobile devices, even desktop devices of users, they they do not have infinitive, uh, let's say, resources. For example, they should be turned off. Maybe they lack some, let's say, resources such as CPU, or they don't have enough RAM, they don't have enough GPU to run the machine learning models. And also, since since there are majority types of client devices, targeting them is very hard because we have to treat each of the device carefully. That's why I decided to quit this approach, and uh, I have come up with this new architecture. You can see that this consists of three um parts. You can pay attention to this ML cloud. So this is the same as the previous one. So we still have this machine learning marketplace, and the client, uh, the, the application now runs on the cloud manager. You can see on the top of this architecture. So this cloud manager is just a server which runs on Linux, and it has two components. The first component is this um, web application. uh, so I called this web application as auth and Docker manager. So it will have a UI for users and backend. So this web application, the main task is to handle authentication and authorization of users, and also manage Docker. That is, each Docker image will be attached to a single user. So you can see this Docker, Docker that we can uh, create many instances of Docker images as we want. Since this is server, we can extend its capabilities, such as add more RAM, add more CPU, add more GPU, and users will not suffer the limitations of their devices, since their task is being run on the server, right? So they will just start the process, and after some while, they will get results. So if we talk about Docker images, so these each Docker image, they will also have web application, which is whose main task is to uh, is to give, let's say, is to implement Telegram client, and also execute uh, machine learning models on these Telegram clients. So this is also consists of backend and frontend. We can see, and this Telegram client uh, will be on the will be implemented, and the files of this Telegram client will be stored on this Docker image on the server. So since these uh, Docker images are separated from each other, the content of this web application, of each web application, will be only available for users. So by doing so, we address the security questions. And also, since Docker shares the resources of the operating system, it allows us to have more flexibility. For example, the same server is being the resources of the same server is being shared among several users, among several Docker images, and at the same time we are also supporting security by separating these Docker images, right? So this idea seems to be more advanced, since it addresses all the issues that we found in the first version of the TeleML. So, what is done for? So this machine learning marketplace is done. So a bachelor student that did his summer internship in my under my supervision is ha, had developed this machine learning cloud. So we can even have a look for this at this web application. So this is just a machine learning marketplace. You can see it looks like a Google Play Store. So here we have a category of machine learning models. They will be divided into categories. We have login and register functionalities. So ML developers can log in into their accounts and upload their developers. For example, if we choose some machine learning model, we will have something like this information about this. So we have a name, the developer, the description, updated. One was this model updated, the current version, size, requirement, Telegram version. So since model should be able to handle Telegram format, I mean the message, the data in Telegram format, we will now. I am thinking about to attach uh, models to the specific Telegram version. So at least we will have something like me required mean Telegram version. So how many installs were made uh, for this module and developer info. So this is the machine learning marketplace. So it's almost done. So we can use this at least as prototype. The next part is this Telegram client. This is in progress. So currently I am developing the front end. So here it will be uh, something like Telegram client. So we users will insert their phone number. So here now everything, all the data is test data. I mean mock data. So these are not the real data. So I'm just developing UI. Then I will um, switch to backend. So they will enter the code that they got from Telegram. After that, they will have something like this UI. So we will have a list of chats, so they can paginate over chats, and whenever they select on some chat, there will be a list of messages, and there will also be a option to apply selected model. For example, if they chose sentiment analysis, for example, this model will be run on the selected chat. So this is the idea of this uh, web application, which is meant for Telegram client. So and this cloud manager has not been yet started. So I am currently uh, developing this Telegram client, and I hope that I will finish all the development this semester. So the, this semester in 2021. So uh, as you pay that, as you probably uh, paid attention, that mostly I am talking about technical details. So I hope this project will be something like a large project, and I hope we can publish this uh, the outcomes of this project into some good journals. That's why currently I am mostly focused on the technical part, and I hope, and at the same time, I'm also trying to uh, analyze the chosen architecture, and I think the chosen architecture is quite new. I haven't found something like this approach, so we can propose this approach and uh, let's say analyze its advantages and disadvantages, and I hope it will be something good outcome. So this is my progress so far. Thank you for your attention.